If you know JWTAs, you already have the right instincts: claims, signatures, keys, and verifiers. In this module, we'll shift that model into verifiable credentials, where credentials are issued to holders, stored in wallets, and presented with proof when needed. So far, you've built the big picture. Identity can be centralized, federated, or decentralized. And VCs involve issuers, holders, verifiers, and DIDs. Next, we'll connect that model to familiar web tooling: JWTs, JWS, OAuth, and OIDC, so credential flows feel easier to compare with login and token flows. JWTAs are a useful bridge because they already teach three core ideas: claims, signatures, and verification. In sessions and APIs, a JWT usually proves something within one application context, such as access or login state. Verifiable credentials use similar trust mechanics, but the model shifts. The issuer makes claims about a subject. The holder can carry those claims elsewhere, and verifiers can check them independently, with more attention to lifecycle, presentation, and user control. A JWT is essentially a compact claims package. The header describes how it is protected, including the algorithm and key identifier. The payload carries claims such as issuer, subject, audience, issue time, and expiration. JWS is the signing layer that protects those bytes from tampering. To verify the signature, the verifier finds the right public key, often through a JWKS endpoint. This matters because many verifiable credential formats reuse these same JWT patterns. JWTs and verifiable credentials both carry claims, but they are designed for different purposes. A JWT payload is usually compact and audience-specific: issuer, subject, expiry, scopes, and enough information to support an authorization decision. A VC uses a richer data model: context, type, issuer, credential subject, issuance date, and proof. Some fields map loosely, like issuer to issuer, but the mapping is not always one-to-one. VCs are built for reusable identity assertions. In JWT-based systems, trust is usually server-centered. An authorization server issues a token for a specific audience, such as an API, and that API consumes it. Verifiable credentials add a holder in the middle. The issuer gives the credential to the person or wallet, and the holder chooses when to present it. The verifier then checks issuer trust, signatures, expiration, status, and presentation rules. That shift enables portability and more user-mediated consent. Verifiable credentials commonly use two proof families. JWT-based credentials wrap claims in a compact token signed with familiar JWTs and JWS tooling, which fits well with web APIs and existing identity stacks. Linked data proof credentials attach the proof to a JSON LD document. They focus less on compact tokens and more on shared semantics, graph data, and extensibility. The right choice depends on interoperability needs and ecosystem fit. A JWT VC packages the credential as a signed JWT. Existing JWT tooling can verify the JWS signature, resolve the key from KID and JWKS, and run familiar token checks such as issuer, expiry, and audience. But that is only the outer layer. The VC claim still needs credential validation: expected type, correct subject, current status, matching schema, and whether this issuer is actually trusted for this claim. With linked data proofs, the credential remains JSON LD, and the signature information is added in a proof field. That proof names the signature suite, includes the signature value, and points to a verification method, often a DID URL. The verifier resolves the DID document to find the public key. Before the signature is checked, the JSON LD is canonicalized, so equivalent structured data produces the same stable bytes for verification. Standard digital signatures usually prove that a whole credential was issued and has not been changed. Selective disclosure adds a privacy layer. The holder can create a presentation that reveals only what a verifier needs, such as being over 21 or having active membership, while other attributes stay hidden. BBS Plus is one signature approach that supports this pattern. For now, treat it as a preview of the privacy-preserving flows we'll revisit later. Key management comes down to finding the public key and proving it was allowed to sign. In JWT, the KID header selects a key from a JWKS. In DID-based credentials, the proof may name a verification method, such as DID example 123 key 1, which resolves through the DID document. The verifier asks the same core questions. Does this key belong to the issuer? Is it active? And was it valid when the credential was issued? If you know OIDC login, VC issuance should feel familiar. A user is redirected, authenticates, gives consent, and receives a result. In OIDC, that result is usually an ID token or access token for an application. In credential issuance, similar trust and consent steps help the issuer decide what to issue, but the output is a signed credential delivered to the holder's wallet. Profiles like OpenID for verifiable credential issuance formalize this pattern. Presentation flows change the handoff. Traditional apps mediate access with tokens issued for a specific application. ID tokens, access tokens, or session assertions. In a verifiable credential flow, the verifier asks for proof, the holder reviews the request, selects credentials or claims, and the wallet builds a verifiable presentation with holder proof. The verifier validates signatures, trust, and policy. Profiles like OpenID for verifiable presentations help map this pattern back to familiar OIDC interactions. When migrating from JWTs to verifiable credentials, do not treat it as a simple token swap. Start by defining who issues, who holds, who verifies, and what each party is allowed to trust. Choose proof formats for your ecosystem, not just your preferences. Plan storage, expiration, revocation, status checks, and key rotation early. Most importantly, keep cryptographic verification separate from authorization. A valid signature proves integrity. It does not automatically prove the credential is acceptable for every decision. The key shift is from app-specific tokens to portable credentials controlled by the holder. JWTs, JOS, OAuth, and OIDC still matter, but they now map into new trust patterns. Next, we'll build the crypto foundation, public keys, signatures, and the proofs that enable privacy-preserving verification.